Behind the meter, Spanish industrial electricity billing engine. Today, we're going to build an engine that computes the electricity bill with practical cases based mostly on industrial consumption and see which are the components of the bill that affect the most, which ones could be controlled because of the market dynamics, which ones cannot because of regulations inside the physical constraints that you have when operating a grid from the transmission system operator. And in today's live streaming, you're going to see all of that programming hands-on, vibe coding the program and placing it into a dashboard in a live web application using technologies such as FastAPI, Pydantic to validate, Pandas to manipulate data tables, OMIE, which is the market operator in Spain for energy markets, and many other components that we will see throughout today's session. First of all, let me put you into context of these live sessions that we are running every week, many formats. You can visit daytons.com/streams. If you subscribe, you'll get a weekly update on everything that I publish online, which are Python libraries to work more efficiently with the programs, also tricks to know better how to work with data applications. In this case, upcoming two live streamings, we have today's Spanish energy billing engine. Tomorrow, we're going to have another one in Spanish for Python ESIOS, which is a library to work with Spanish energy data. Tomorrow as well, after that, we are having Python NSOE and Python EIA updates, where I have developed really cool features into the web application. If you go to the blog, you will see what we have improved. For example, if we access US energy data, I have embedded the skill so that Cloud Code or any other agents can know how to query the API without you having to write a single line of code. Here, it's the setup, very basic. You install the library, set up the secret configuration, which you can request here, and then you add the skill to the project, and Cloud Codes can now execute commands like this to explore which are the routes of data endpoints. You get the data, in this case, for example, CISO, which is California Transmission Operator, CAISO, and here from a start date and an end date. You get the data values, and even that, you can later pipe in the pandas data frame manipulation so that you can operate the data using the API CLI command line interface. But at the end of the day, even though you see code here, Cloud Code, the AI agents, will do all of this for you. You just need to tell what's the average generation by field type for CAISO last June, and here it will sort it out. If you want to export it to CSV, here you have it as well. So very easy to work with AI these days. And here you have got some other examples. If you go to the other post, you will see practical cases of real data being queried. And here you can see the data points, tables, charts, all the type of indicators that these APIs have to offer. So this is about Daytons.com streams. We are every week live streaming the recent developments that we are doing, which are many. Here you can see the apps. Today we are going to build the application for the energy bill, which will be placed in here, and you can use it right afterwards if you want. There are also many others like consulting legal documentation. Take a look if you want. And now let's focus on the live streaming. Also, if you got a data challenge and you think we can collaborate on a project together or meet each other to explore some options, you can give me a call and I'll be happy to meet you and get to know your project and see if we can collaborate. All right, so enough of the promotion here. Let's go back. Vibe coding with the context of today, why Spanish electricity billing is hard. There are sometimes opaque invoices because you don't know the details of each component. There are many layers in the cost associated, which are most of them the cost you pay to access the transmission system. Then you have got losses from the point of ingestion of the energy to the generation. And all of that is barely seen for the industrials, but they are of importance in the bill. Then we have got 6 tariff families with different categories for residential and other for industrials, where we have to take into consideration many files in the raw data to process them and compose the indicators for the bill. The problem is that the naive billing logic breaks too fast, which is what I see many companies or beginners might have. So, or ones that are relying on their internal resources beyond going to other providers. So the one day has 23 hours, another may have 25 because of the hour change, and the billing must handle this appropriately. So this is something that with co-programming we can handle pretty good. Period definitions change mid-year. So there are updates that are published by official organisms in Spain that we need to consider and update manually because they publish the PDFs and we have to take it into the consideration for the calculation. Then we have got the settlement data that arise in 5 waves over 11 months because all the liquidation, I think it's like that. The energy system works in a particular way, and all of that is measured through monitors that have the energy counting how much is going from this point to this other. But there are many other components like losses, because if you produce 1 gigawatt per hour in point A, you might reach 0.95 in point B. So that is a loss that needs to be taken into account into the system. To give you a look about these many files we are handling in this case, if we go to ESIOS Spanish official transmission operator, in the downloads section that we have in don't remember even anymore. I think it was ESIOS downloads. Here we are. So in this case, we have got a Liquicomun, which is the type of file we need to work with, and also the model coef, K, which is a coefficient for the losses. In this case, we even have to go back some months to have such information available. This is what we have here. These are the losses of the system, a parameter we need to consider for the calculation. Let me change to English. So what are we going to do here then? We need to download all of these files programmatically, of course, instead of going here and then I click on the Liquicomun C2. I have got the file here and this is what I get. A zip file for each one of the months. And here I've got many data files that if I am to open it in Visual Studio Code, let's move it here. Here is what you see. Compodem, which is very key. Here we have the components of the bill. Let me close this. So there are many files we need to process in this case. If we take a look better, so all of these files are the ones we have to pre-process. There are many of them, everyone for each day. Here we have more information. So we better process the information appropriately. So there are also many other files we need to consider, like the coefficient of losses, which we can download as well. And if we have it here, we will see the estimations that we need to calculate. And this needs to be processed into a data table to apply the calculations for every day of the month and hour. So a lot of work to do here. Okay, so let's go back to the presentation. Now you know which type of files we are working with. And the loss coefficients vary by voltage, which is based on the type of periods you've got. Some percentage of the losses are applied to you. It's not the same to apply a loss to a 2.0 TD, which is residential houses, than a huge factory with 6.1 TD. Now, the settlement cycles. This is very important because what you saw previously is that in the files, downloads, you don't not only have got the C2 Liquicomun, which is the one we have downloaded, you also have A1 Liquicomun, A2, C2, C3, C4, C5. So there are many of them. How are they published every year? So if we take a look and we are in the current billing month to bill the previous month, we have A1 and C2. A means the advance and C means the closing. The date ranges when this is published is around the day 17, 19 of every month, the A1, around the day 20, 22 for C2. So there is a small period of time where all the participants in the market, the agents, can submit some verifications or some misunderstandings maybe on the bill, so that the transmission operator can review the numbers later, get feedback, and then have more Liquicomun files published in the following months. So for the following month after the first one, we have got in day 3 to 8 the following advance. Then we have got some period of time to verify the information and then close the possible problems that may have or requirements, inquiries from the customers, agents in the market. And this is how we go over the months until the final definitive C8, I think, which is after 11 months. And in this case, we don't have it here because I didn't query as many data. But if we go back up, if I am correct, we should get the the C8, or maybe there is a mistake I did. Anyway, you get the point. So in our case, let's suppose we are a retailer of energy and we are selling energy to an industrial. How are we going to charge them? At which time? With C2. Because with the first one, A1, we get the review of what's happened in the energy system. After they close the verifications, etc., we get enough information to bill our customers. So C2 is the one that we will use. Now, let's do a comparison between naive systems versus production systems, which is what we are going to build today. For naive approaches, we have got hard-coded period definitions like static P1 until P6. And today we will have dynamic periods based on the files precisely so that we get enough precision to apply the calculations. And they are calculated based on the ATR, which is 2.0, 6.1, etc. Now, there are some times that industrials, to get a reference, or to project into the future, they use monthly averages. In our case, we are going to use 15-minute periods from the market operator of energy in Spain, which is OMIE, and then adjustment services for the component settlement, which is individual components that you need to take into account for the bill. And these are services to ensure the safetiness, the safety of the transmission of electricity. For example, when you have solar energy being produced during the day, but there are some hotspots in the system that cannot be oversupplying energy because it doesn't have capacity in the node to get into the transmission, those solar plants, part of them is being shut down. So that's energy you could be producing, but you are not because of these problems. And this type of settlements makes the price of the energy go up because of technical maneuver to keep the transmission system of energy safe. Another type of components to consider into the billing engine. Then we have got a single tariff, only 2.02 TD, which is if I am an industrial and I want only to, or I am a household and I want to make a calculation for myself, I will use just one tariff, which is the one that I am I care the most. But in our case, we're going to build it to work with any of them for residential houses, any type of industry, and so on. Now, we are going to build based on full formulas, having each component precisely in Excel, for example, or Excel type of spreadsheet, and calculate the formula that you get at the end, component by component. And then another thing that we do on a naive approach is not considering the coefficient loss, which is the file we saw before in the Excel. So we're going to take the original data, plug it into our system to get precisely numbers based on the ATR to calculate the coefficient losses. So in today's stream, what we are going to do is building an API, an endpoint, so that we can query the calculations, run them, validate if they are good, and get the breakdown in a PDF. The architecture of how the billing engine is going to work, first, we'll get the inputs from a consumption file of the factory. Then inside the billing engine, we will get data which comes from the markets, other data which is regulated based on the calculations, and the FastAPI will break down in a JSON the final numbers. So we have got components like OMIE, the columns for settlement, the adjustment services. From the government, they establish based on studies the cost of the access to the system to the energy, the losses, and also the taxes. And finally, all of the families in the type of tariffs. The tech stack that we are going to use is Python, FastAPI, the OMIE web app, where they have got the data, the CNMC, which is the Spanish supervisor for setting the information, pandas, and clouds codes. So without further ado, let's get started with it. In the Visual Studio, I'm gonna open the project. By the way, if you have got any doubt while I work in the stream, please let me know. So I'm gonna take the code, copy here. So I'm starting from a solution that I had already developed, in this case for the engine, and we are gonna put it into production. So the ultimate goal is to have it in the websites. For example, I can run it in development mode. Let me do it here. By the way, I think you can hear me. Yeah. So the server is running. Let's open it up. Here we can see it. And I want to build a new application here for the calculation. So maybe we can have it on APIs. So I'm gonna tell it one second. Yeah, it's okay. I'm gonna build an engine to calculate Spanish electricity bill for industrials and many households, etc. Here you have got the codes. Take a look into it. But first, let's focus on building the front end, which I want it to be in an app. So find out which route we should build it. And now the agent is going to look into my system, where we have a repository. Let me open a file. So in this repository, close it up. Okay. So in this repo, we have got all of the files, the billing, how to calculate. If you go here, you will see the fast API, part of the schema, how to get the tariffs, how to upload a PDF, etc. And then we have got the whole folder for the website, which is daytons.com. I have separated the front ends, and then inside here, if we go to the routes, which is inside SRC, you can see that we have got the structure of my web application. You can see here, for example, blog. You can see the apps where I have got energy. I have got the NCPs. So from here, where we have got the apps, legal APIs, NCPs, let me execute. I want to list another one, which is going to be for the energy bill. So I want to have another space for the energy bill calculation. I'm going to ask the calculator to do it. And here they are suggesting that they want to place it in energy billing, which is going to be another type of application. But I want to keep this separated as a microservice. So since it's going to be an API and an NCP server, let's put it there. Yeah, that's it. Now let's build the front end for this. Let's make first the landing page, and then let's put the playground for the calculation in a sub page. So now the agent has gotten into plan mode to explore the information insights of the repository, gather all of the information based on particular things, which is the pattern that I am using in each one, also for the messages, because we're going to do this application both in English and Spanish. So this library is the technology we use to localize the information. Now let's sit and wait. Meanwhile, let me show you something that's it's already available. So if you go to the Spanish BOE, which is the official gazette where they publish the political stuff, legislation, etc. How can we access this information through the chat? Because right now I need to get into the PDFs, etc. I don't have a reference, and maybe I want to search across all of the files. So I built a tool where you can precisely search the Spanish legislation in detail, but I don't have it available. Give me 1 second. So right now they say that the API is currently unavailable. I'm gonna check in the remote, which is through SSH droplet. I'm getting into an online machine that I have. Let me hide this. That's okay. So inside this machine, if I go to the legal docs, which is the repo, I can ask the chat if this is working or not. Let me create a new the API running. So they say the API is running, in which URL is being served. In the other chats, I can ask why. I'm gonna build a new one. New chat. Okay, let's work in two applications at the same time. Now it's uh, yeah, because I am in a development server and I had wired it so that it's using the local development server, but I want to have it in production. So let's change the production URL. This is happening because you see that I have got a legal API URL and also the local host. So in the remote computer, which I have in here, the API is running, but it's running in a remote server where I am serving it through this variable, this URL. However, in the local development, which is using this environment file, I have got the localhost URL. So I need to change it. Change it to use production or yeah. And after that change, I should be able to see it in the front. The thing here is that it's okay. I'm gonna take this moment to walk a little bit. I'm back. There's a cool thing that I like to do always is that every hour I put the desk up and I have a walk meal so that I can move the legs. Being the whole day sit down is not good for the health. Run dev. So now we should have it. The front-end web application. We have got the billing. We have also got the legislative coverage. This is how an API connected through the front end can work. For example, if I say here the storage in Spain, which is almacenamiento, I can search throughout the whole official gazette. Also, if I go to the energy bill, here I could search for anything like almacenamiento, and here I can see the specific places where it's being mentioned without having to navigate throughout all the many documents inside. So very cool. Now, let's go back to the energy bill calculator, which we should have already here. There we are. I click inside. I get the hero, the landing page, instructions to connect through an MCP server, and the type of calculations we can apply. So we can try the playground. I don't know if the chat has been able to interpret everything and even we can apply the calculations. Let's give it a try. So if I want to calculate from January, I want to be a fixed price. I mean, this is gonna be pretty easy. 1 sec. If I try to calculate for a fixed price, is it working or not? So, okay. Okay. Mm, can we use the localhost URL in the environment file and run the server for the API? But yeah, let's do it here. So because the chat in this program has got the access to the files that I have also got here, where we have the API with the endpoints on app.dxl with the data, consumption, blah, blah. We can actually also run it from here, and then it has access to both codes and services that we can use to trigger the information, the APIs. Gonna have all right, so the API is running. You're getting the results. So now we should be able in the web app to calculate based on the fixed prices and get the information. There we go. So now, what can we improve from here in this playground? Mm, Would it be possible to have a sidebar where I can choose? We have the input widgets of the calculator, and then we have got the dashboard with the charts and any other information from the bills calculation, but with charts and numbers, like a kind of dashboard. Wait. They say that there is no charting library installed, so I don't want it to go on its own. I'm gonna use this one. So cd front end, I load, install the components. Also for the sidebar, They're asking if I'd like to overwrite. Uh, I don't really want to. Inputs. Oof, nah, no, no, no. Let's say we have just installed the components. So we have got many chart types that we can use to display the information. And this is what the agent is going to apply in the calculation. Yeah, if we are calculating now for the index, we get this error. So let me check this out on the sides. Let me use this here. Let's open the cloud codes and say, I'm getting this error. Import fix it so that it might be also that in the data for the components, we have got the information in the COFK, which is the components of the losses in the electricity system. There is a problem with the dates. So, wow, this has changed quite a lot. What? Ooh. Here we have got the bill. Bill. There is some spacing that I don't like here at the top. There is a blank margin at the top that I don't like because it makes it feel very empty. Check it out. Let's put the image. But yeah, I mean, also, yeah, that's also another thing because right now we haven't put anything from the client. We should put the energy that the customer has consumed into the calculation. So no, that's too much. Okay, so now I have got another problem because theoretically, if you take a look at the repo API, you have got many consumption files from customers, but I don't see a place where I can upload those files and then have the calculation, which is a three-step process, I think. First, you ingest the data, you normalize it, and then you apply the calculation. So now the system is going to place in the front end the widget to upload the file of consumption, and we can have the customer data visualized and multiplying the mathematical equations of the bill. Pico. One kilometer. También otra de las cosas que vamos a hacer en el sistema es que el usuario pueda elegir el tipo de liquidación que quiere. Entonces, si yo me vengo, por ejemplo, al final de el 24 y vemos aquí todos los Liquicomun, pues le vamos a decir al usuario, oye, ¿cuál quieres utilizar? Y ahí lo va a tener. Mira, aquí ya podemos subir el ficherito. ¡Bum! Entonces vamos a irnos aquí. Le vamos a decir que dónde están los ficheros que estaban aquí en el Excel. Data, consumption. Mira, aquí se ha inventado una gráfica, unas tablas de datos de, por ejemplo, fábricas que hacen cerámica, procesamiento, estampado de metal. Vamos a ver la del cerámicas. Te voy a meter para acá. Vamos a la al front y le vamos a decir aquí cerámicas. Subimos, pero no me deja, ¿no? We should be able to drag and drop a file. Now we are getting out of context. Here you can see, and I wanted to write the plan so that I can clear up the context, but we're 95%. Let's do it. Now we are in 0%. This is one of the greatest features they have developed from Anthropic, because now I don't need to worry about losing the context from before and having to compact. All right, so enough walking. No, they killed the front. They killed the front. Now it's running again. Okay, so I guess that I can drag and drop ceramics. I think when we forked the conversation and there were elements running in the bash, they walk away. I'm gonna do it here. There we go. So now we upload the data. When they say daytime modes, single or separate. If it's separate, we need to specify which are the columns. However, maybe this would be better that the form is sync with a viewer of the file. I think it would be great to have a viewer of the file in the front so that the user, at the same time that is selecting the mappings and the configuration of the file for normalization, it can also preview the data file. Okay, so data source. So I wanted to check it out by itself. So vive coding 05 Spanish energy bill. Check it yourself, boy. Check it yourself. But I mean, I mean, how could I make it so that at the same time the user is configuring the stuff in the front end, I get the preview and immediate feedback about what's wrong, etc. All right, let's do it. Now it has entered the plan modes, and I fear that if I accept the process that I was running, it walks away. It gets killed because missing context, it forks a new conversation, it seems. So let's check. But maybe I cannot, I can pass on forking. So I'm gonna just and bypass because we have got enough context. Nah, it's okay. So it's gonna do all of this. Then we can get feedback and the visualization preview. So this is gonna be good. We should see a preview of what's going on. Meanwhile, I'm gonna work on the other projects. Who's here? Was one of the cool things of vibe coding is that you manage your team of developers. Here I have the one running on the front end, and here on the back end for the other application, which I don't know if it's working properly or not. Okay, so it's done. Let's reload. Let's add the file, and we should see a preview. Ole los caracoles. Ule. Está tremendo. Esto está tremendo, loco. Tremendo. I think we should change this, and also, but okay. Also add some chart visualization. Differentiating the but it's quite good. I like it. So we get the raw data and then the energy, where we can specify also the units. Should be kilowatts per hour. But the chart should also be seen during the preview. So let's load the full data and catch it whenever you find a good one, so that the visualization can always stay the same. I don't know. Whatever you think is best and more robust, scalable. It's now building the codes for the chart. got an error. It's been detected by the agent, so the agent itself it reinstalls. And now if I upload, there we go. Amazing, amazing. Mm. So theoretically, now here we upload the consumption data. We get the preview. We could zoom in the data, but probably we need to wait for something. I think for the consumption data section, we could have it collapsed and collapsible, and by default it's opened, so that in case the user already knows, they can leave it there. So it's normalized, ready, and then here we can calculate the indexed pricing, but no, I think it's okay. Leave it there. So here in the energy column, the unit is the kilowatts, not kilowatts per hour. And then here we normalize, and because of this, we can calculate now the proper billing. And here we get the periods, consumption by periods, the number of hours, sample data. Also, after the calculate, I would like to see far more information, and not only that, but I would like to also interact with information and different type of charts like heat maps, and where maybe I have the heat maps differentiated by periods, also charts, many other things. Like, which many charts do you propose? Yeah, because the hourly data frame has got many information, so we could chart most of that. Uh, 5 focus charts, heat map. Let's do that, because here we have got many options, but uh, it's going to start with the essential charts. So let's see how it goes, and then we can move on to other things. All right, let's do it. This is the one that I would like to see. Stack bars. Then, okay. So the front end here, if you take a look, it's recreating like the coloring for each one of the labels. So it's gonna be very interesting to see how they compute. These guys should change that whenever we pass from plan modes. Like when you develop the code with Python, if you just copy paste this error, you should know enough context to solve it. And now I got another error. good. No. Yeah. Okay. Now we normalize. The data is ready. We can calculate. Now this is another thing, but could we persist the information even if I reload? Great. Sometimes I ask to search in the official documentation so that it doesn't hallucinate on what the library Svelte can do for us. And this is a better approach. Another thing that I wanted to do is to have a kind of inline formula to create my components. So now, let me reload, move the file, normalize, execute. There I go. So I get all of this. The average price, the cost breakdown, the price distribution, and the results. Yeah, I mean, I think it's good. What about the heat map? Also, I mean, I don't know if we should do it, but maybe a heat map for components so that the customer can see what is the real cost, or in which parts. But this is something that I don't like. I mean, when you have the formula, there are a lot of data and components you get. So now I want to change the way we proceed with the calculation. Instead of using a widgets inputs, I mean, that's good for the dates and also choosing the ATR. However, to specify the formula, I think we should let the user define their own variables and explain them which are the components they can play around with, and also which are the typical formulas that they can apply if it's an indexed price. But of course, if it's just fixed price, you just put the thing here and that's it. And in this case, I think that we could have a template for the index price even and directly apply the periods that they can use for such a index price, available, or give them the template, the values of with the widgets. But I want it to be like they press the dollar sign and they can write the value, the variable of a formula, and they can compose any formula they want. Like I want them to have the power of selecting from templates the formula and then modify such a formula. So let's see, what did they do? That is it. I don't have any in mind right now, but please put some of them uh, however you see fit based on the knowledge you have. For the fixed pricing, all right, let's leave it as it is because otherwise it's gonna be a mess. But also maybe you should give the option to the user to add more values or variables to the fixed pricing. I don't know, because is it reasonable if they have more things to put in top of the fixed pricing, or maybe they can directly put the formula of the fixed pricing? I don't know. And now for the third, yes, it should show the autocomplete dropdown of available variables. And also make it that whenever the user defines a variable in the first line, that variable is available in the second line. So like you register whenever the user is done with a formula and you keep track of all of the items in such a formula line by line. The plan, the perfect plan. These are all questions of UI. What is it better? How we should do it? It's gonna be interesting. Ba-bam. All right. So we have got two ways right now. Either we have a fixed price, we calculate the energy, and here we get, but I think here is not considering the data file. Now they should. Anyway, um, if we go with index sets, here we can get the formulas. However, they cannot see the full pass through. Add a step, drag and drop. ESIOS here, bar. dollar. Yeah, this is good. Should we have a way where in the down of the templates, which shall be a combo box that can be filtered while the user is typing, to have a kind of mm, side like detail button in the same option where the user can click to open a modal that shows the information of such formula? Because sometimes if the user goes through here, but they don't know what they are going to do, is what it's the meaning of these formulas, it doesn't make sense. So they should know. And I want to put a button here that they can click and something shows up explaining what it is. However, I think I already had done this in some other application. I think it was the energy dot. I think I had a component that does this precisely in these projects. Can you look it up? Let's see if we can publish this by next week. And I can give a showcase how it works. There we go. But 1 second. But 1 second. When you display the modal, it's meant to inform the user about what each component means. I think you can consult this information if you look up the ENSOI library. I don't know. I mean, right now, if you take a look, we have more information about what is the meaning of each component, but mm, still there is something that I mean, I think is good, but mm, here are the components. Y- Also, I think we can simplify the user how to look up the meaning of each component, which can be, while in the modal, if they hover in a component, they can see the information of the component and the source, etc., so that they don't have to look at the formula and down clicking, going back and forth. Also, there is another issue that some words are cut and put in the following line in the same from the same the letter in the following line from the same word. Let's grab it based on the plus signs or any other sign. Or even better, I think we could have like it's okay. Improving the user experience. Also, I don't know why, but oh, they can see it. There we go, boy. There we go. Now, I think that writing the formulas in the sidebar is a bit complicated because it doesn't fit. I don't know. What do you propose for letting the user write the formulas? PO, propose options for the calculation. Should I vertical? I mean, I think I like the drawer. Mm, I think the slide out drawer, yeah, because we can hide it to focus on the charts and toggle it up to focus on writing the formulas. That's awesome. Let's do it. Let's do it. I'm pressing enter. No. the drawer. Let's see it. But now if I want to edit the formula, I get it here. And I mean, that's okay. But yeah, I mean, we can see the information here. But. Could we make it so that we can write one component at a time, and whenever the user keeps the mouse over a component long enough, it shows the information of such component, or if they click on the information button? But I think maybe we shouldn't have both ways of I mean, we could have both ways of the information of the formula templates, and also for the individual ones in the formula editor, the information of each component if they hover long enough. Uh, but but oof. I think it's gotten very messy. Like, what do you propose to handle this of letting the user get the information of each component and then also see the information of each formula template? I think I'm gonna keep it simple because otherwise I'm gonna get stuck into this. We're gonna build such a big component for calculating Spanish electricity bill. Wait and see. Okay. Calculate. See the formula. This is amazing. System operator. This is amazing. This is amazing. Let's wait. Let me check in the other projects if not this one. Oh, last ingestion was today. So have there been like missing documents we couldn't process, ingest into the system? Let me know. All right, so let me go back up. Okay, so now shouldn't we add a description about the template formula itself, like a general description? However, don't you think that for the description of the formulas, we should keep the modal? For the components, it's good the area below the drawer. inside the dialog, I think it'd be interesting to have the same dynamic drawer for when the user hover the mouse over a component inside the modal. Let's use a drag and drop for moving the line items of the formula. The items, the drag and drop icon should be in the left side. There you go. Bespoke. Let's give it a try. Oops. Ole. There should be a button to reset the template formula. Where is the reset button? Ah. So if I modify, I get the resets. Amazing. Amazing. Man. I don't like when you wrap formula items in the dialog. What should we do? Proposals. And shouldn't we have more spacing between line items, like each formula inside? Shouldn't we have more space between items of all of the formulas? That's good. There is a problem when we have a trailing parenthesis because the sub- the hovering doesn't work. For example, cargos. So if we put a margin of 3, we're done. Calculate. Let's calculate. Now, could we have a heat map or now could we have a heat map where the user could select the components and visualize the information throughout the whole period, having on the x-axis the days, on the y-axis the hours or the least granular interval, like 50 minutes or the hour. And with this, let's go to deployment. Let's see if there are some heat map in here. All right. So meanwhile, I think I'm going to push this repo to the clouds. So I'm going to open a new conversation. Code. I want to deploy this project into the remote server that I have got. So I think we need to copy the folder to be in let's deploy this project to be in ncp.daytons.com, following the same pattern as we have in the other apps. let's deploy the energy billing in Spain projects following the same procedure, but in another port that we have used in legal docs. This is a project that I have here, the legal docs of the Spanish official gazette. And I have it with a structure of Docker Compose for development and production, with project files in here, and also the NCP server. So taking advantage of the structure that I have already built in there, I will develop the energy bill Spain. So AI, the agent, is going to look into the legal docs, and from there it will specify the Docker configuration in energy bill Spain. And meanwhile, let me close this. It's okay. Uh, So we should have already the heat map. So if we calculate, we go down, but I don't see the heat map. Oh, so let me check if I can use another formula. Don't calculate. No, but I don't see the heat map. Ah, I think it's because of the hourly. No. So they have deployed it on this port, and the Docker file should be here, which is correct. Is it through nginx ncp.data? Uh, Oops, I gotta go. Okay, guys, so mission accomplished. At least we had developed run dev. All right, guys, so mission accomplished. Today's goal was behind the meter, Spanish industrial electricity billing engine. We wanted a front end where we can place the configuration of the formula, and through an API that uses OMIE data, formulas from the official Spanish legislation, we could get the result and some charts. And that's precisely what we have built today. If you see here, we had generated some formulas that if I drag and drop the consumption file of a random factory we made up, we normalize the information by selecting like how is the daytime, which is the column, the energy. We normalize the data. Here is ready with some information with the peak, etc. And now we select the starting dates, which we are going to place, for example, between these two. And now we will calculate a formula which we can select or fixed or indexed to day ahead prices. We edit the formula. Here is the meaning of each formula template that we can display in this case. If we hover the mouse over each one of the components, we can observe what are they about. We apply the template, the formula is replaced. We can add other steps. For example, here, like cost, we can say some expression with the dollar sign. We can specify which other components for this new formula item. And now we apply the calculation. By the time we calculate, we get the charts and the information that we need to display the results. Let me check 1 second. There we have it. And now we can see the whole information, even in the heat map, and also the period distribution. There are some things that we need to fix and we'll do, of course. If you want to stay up to date, go to the apps. And if you want to register, click in the Spanish Energy Billing NCP. And there you will have a access to get the information. That's all for today. If you want to learn more about us, please, on next streamings we are running. Tomorrow we've got two, another in Spain, one in Spanish and another in English, to showcase you how to work with Python libraries to analyze energy data. If you want to stay updated and get the recordings, leave us your email and we'll send a weekly updated with all of the content that we are publishing. I hope that you enjoyed today's live streaming, and I'll see you tomorrow.